guys? Hi, welcome back. We are on day 7. This is still chapter 6 about exponential functions. We are moving on to example 2. Today we're talking about transformations, okay? So the good news is that we've done 100 transformations. We've done so many of these, and the rules are typically still the same. It's just going to look a little bit different because now we're using an exponential function. So hopefully you guys will be able to rock this out because of the familiarity of it, okay? So we are looking at a problem that says to graph the function negative 4 to the x plus 1 and then describe it in terms of its transformations of the parent function 4 to the x. So that's this function right here. This graph is showing us the original function. Remember, parent function just means original function. And so that's what we're looking at on the graph. So before we start on that, we need to talk about the generic form of an exponential function and then how the individual pieces relate to the transformation, okay? So when we are working with an exponential function, we have a times b to the x. And then this part should, we talked about that last video, this part should look kind of familiar. By the x, there is a minus h. And outside the function, there is a plus k, okay? So remember that h stands for horizontal, so that's going to be your horizontal shift. That k is your vertical shift, but let's go piece by piece. So your first piece is your a term. Remember, if you can't see the a term, you can assume that that number is 1. Whatever a is, if it is negative, then that is a reflection over the x-axis. Okay. Remember the b, if it's bigger than 1, it's growth. If it's less than 1, it's decay. We're not really worried about that right now, but it's just important to remember. So we've talked about our transformation. Oh, if our x is negative also, sorry, before I get ahead of myself, that is going to be a reflection over the y-axis. Okay, so reflection over the x-axis means it reflects up and down. Reflection over the y-axis means it would reflect left and right. But now, so for the h and k, remember we've talked about transformations, and if you've had me in class, then you know that I talk about the container all the time. The container can be square root, it can be parentheses, parentheses squared, absolute value. What other things have we seen this year? We've seen the denominator of a fraction. All of those things are considered your container. And that container always contains that horizontal shift. In exponential functions, our container is going to be the exponent, okay? So we can add the exponent to our list of containers. So that means that the h in the exponent is your horizontal shift. And then hopefully you should know the next words coming out of my mouth. You know that the horizontal shift is counterintuitive, meaning that negative is going to go right and positive is going to go left, okay? Other than that, the plus k on the outside, remember the term that's always on the outside is your up-down shift, so we call that your vertical shift, and then it's exactly what you think it's going to be. So positive goes up and negative goes down, okay? So using this information, we can look at any new version of an exponential function, and we can list what the transformations are of each one, okay? So I've got my new function, negative 4x plus 1. I'm going to go piece by piece and list those transformations. So the first part, I have a negative on the outside. Remember, that's my a term. I can't see a number a, so that negative is like an invisible -1. But it's there. And so because a is negative, I can say that there is a reflection across the x-axis. Moving forward, I've got the 4, and then I look up in the exponent. There's no shift up here in the exponent, so there is no left and right shift. And so my next move is my +1 on the outside, okay? So I would say that this is a vertical shift, and then remember, vertical is exactly what you think it's going to do. That positive, that +1 is going to mean up 1, okay? So what that's going to look like in terms of our graph, the first thing I'm going to do is I'm going to reflect it across the x-axis, okay? So remember, that means that if it was opening up, I'm going to do its mirror image going down. That's my reflection across the x-axis. So I'm just going to look something like this, okay? But that's just the reflection. Check, we did that. Now we have to shift this function up 1, okay? So that's going to look something like this, okay? So that purple one is actually, ooh, perfect. That purple one is actually going to be my graph of -4 to the x +1, okay? So let's talk about some things that change. Okay, my graph isn't totally perfect because my y-intercept should be right here at the origin, okay? Typically, the reflection would have mapped if this original y-intercept was at 1. When I reflected it, it would have gone down to -1. That would have been the reflection. But then when we shifted it up 1, my y-intercept is now, ooh, darn it, is now at the origin. So I'm going to try and draw. Okay, that's a better one anyway. So my y-intercept has moved. It was once here. Now it's here at the origin, okay? So we're going to note that our y-intercept is now at the origin. And then we're going to look at our asymptotes, okay? So the first one, the original 4 to the x function, we can see that its asymptote, remember asymptote is that invisible barrier that your graph will never cross. It will approach it forever, but it's like an invisible fence that it'll never cross, okay? That was originally at the x-axis, kind of like it was in the last videos that we did. Now that we shifted it up 1, this is going to result in the asymptote also shifting up 1. So the asymptote shifts up 1, which means the line that's the x-axis used to be y equals 0. Now, since we've shifted 1 up and our new asymptote is up 1, it's at the line y equals 1. So we would say the asymptote is now at the line y equals 1. But if you know that the vertical shift relates to the asymptote, then you know if the vertical shift is up 1, then the asymptote moves up 1. If the vertical shift was down 2, then the asymptote would shift down 2, okay? For transformations, remember, you can always graph them. Graph your parent function and then graph the new one. And that'll help you kind of itemize what happened to each asymptote and the y-intercept and, you know, reflections. Remember, I would recommend the Calculate 84 app. Hopefully you guys were using that during trig. It is right here. I can show you. It is on my bottom row of apps. In the middle, it's the pink calculator. It is totally free. TI 84 also has its software available for downloading. It's free right now because of the online learning that's taking place. So if you Google the TI 84 software, you can download that as well. But I know a lot of you guys are on your phones. This one is incredibly mobile friendly, and you can graph your two functions and then you can view them on a graph, okay? You can also always use Desmos online. Got an app for Desmos right here. It's an awesome online graphing calculator. You would just type, you know, your y equals blah, blah, blah over here, and then it will show you the two graphs, okay? So you guys have a lot of ability. Again, Desmos is a really good app, really mobile friendly, again, for my friends that are using their cell phones, okay? So I hope that this was helpful. Make sure you're emailing me, remind me, Google Classroom me, whatever it is that you need. I would be happy to help you guys with anything. Yeah, I miss you guys. It's been a really long time, and I wish that we were in class, and I love you so much. And yeah, have a wonderful day. Bye-bye.